Hello, today I'm going to be talking about IPCs or inter-process communication. IPC is a important and vital concept in operating systems and computer science. IPCs enables different processes to communicate and share data in a multitasking environment, which is a essential concept as it's becoming in our world in operating systems. IPC is essential for coordination between processes, whether it's for either sharing information, synchronization, or even like command line tools. Let's start by understanding pipes, and that is one common and the most used method in IPCs. Pipes are like conduits or like real pipes or tubes, if you will, that allow data flow between different processes. Um, Pipe usually have file descriptors. The file descriptor pipe 0 is the read end of the pipe, and the file descriptor pipe of 1 is the write end of pipe. In this tutorial, we will understand how pipes work and how two different processes communicate. Some of the important things that we need to know about for learning pipes is fork, parallel processes, and parent processes. Fork is basically a function that creates or takes one process and duplicates into two different processes, generally being a parent process and a child process. A parent process is and a child process, or two different processes, can be used in many different ways. For example, if you have a user input program, you can have the parent process take the input from the user while the child process executes the program. I have written a program over here. Let's go ahead and look into what I have and understand the working of IPC and pipes. So let's go over this code line by line, starting from main. Firstly, I have defined an int pipe. This is basically declaring the file descriptors for a pipe. I have declared it at 2. We're gonna have, you usually need just 2, one for reading and one for writing. We have one extra to check for pipe errors. The next, I have PIDT, child PID. That is a process ID to recognize the child process, because usually when a process is duplicated, the two processes will essentially, because you're duplicating them, they're going to be the same. However, you're going to have two different process IDs. And then I have a char message. This is the message that we're going to be sending through the pipe. We're going to use the write end in the parent process, and we're going to send this message from the parent process, and then we're going to read the read end in the child process, and that we're going to store in character buffer. Firstly, I have created a pipe, and then I check it for a pipe error. If the pipe errors, we exit and just throw an error exit failure. And then we're starting the first thing, which is fork. Usually when you fork a process, two different processes, basically the duplicate of the process is created. And then we create check for fork errors. Usually it's a good thing to essentially check any errors in your code. Usually if your program has errors, a good idea is to exit from the program so as to not let people take advantage of your program. And then we have this if else block, which we treat it as an if else block, but let's view it as two different processes. The if process is basically the child process, and the else block is basically the parent process. So let's go ahead and look into the child process. Firstly, in the first line of code, we're closing the write end of the pipe, and this is so that, because in the child process we don't really need to write anything, so we're gonna close it and it's not being used by the child process. The second line we have is the read. So we're gonna read what is coming from the read end of the pipe. So this is the file descriptor pipe fd0. That's the file descriptor for the read end of the pipe. And we're gonna have buffer where we're gonna store that information, and the buffer is going to be reassigned as the size of the buffer. And then we're gonna print whatever we receive from the read end of the pipe. And then at the end, Usually, as we learned before in memory management, you would like to close or you would like to free all the memory that is user allocated, and when it's not being used, you want to free it. Similarly, when you have pipes, when you're not using pipes, you would like to close the pipe, whether it's the read end or the write end. Notice we closed the right end of the pipe as we created the process, and that is because we were not going to be using the write end, but after we were done using the read end, we closed the read end as well. And then we exit from the child process, and let's go look at the parent process. The parent process, the first line is we're completely closing the read end because the parent process does not need or have any use for the read end of the pipe. And then we have the write. We're gonna write into the right over here. I'm sorry, I keep pointing. It's because I think you can see I'm pointing at the screen. But we have the right end of the pipe, which is pipe fd1, and we're gonna take the variable which contains the information. I think it says hi child process. Yes, it says hello child process, and then we're gonna have this message sent from the pipe to the read end, and then we're gonna close the right end of the pipe, and then we're gonna print what we sent to the child process, and then the wait part. It's usually to wait for the child process to finish before the parent process is over, and then we have a return 0, which is basically telling that we're done with this program. So let's go ahead and run this program and see what happens. Let's compile -G to enable debugging information, the name of our file, and then we have -O to create the object files and the name of our executable. Now I think our executable is created. Let's go ahead and run this executable. Now it says parent process sent hello child process, and the child process received hello child process. So it's basically telling us that the parent process wrote into the pipe hello child process, and that message was received by the child process. Hopefully this helped you understand how pipes work and gave you a little understanding on how pipes or how you can use pipes. I'm gonna have the code open towards the end if you need to go ahead and understand the syntactical sugar of this program. Thank you and have a nice day.